particle moves along a line with velocity equal to 3t squared minus 6t. The total distance traveled from 0 to 3 is, okay, so again, we're going to have to integrate, right? So we would say we're going to integrate 3t squared minus 6t from 0 to 3. But this time, it's not enough to just throw it out there like that. We could have problems. Let's go look at the graph to get a better idea of why we might have a problem. Hopefully by now you're getting the hang of when you hear that word distance, that you're looking at the absolute value of it. By the way, there is an absolute value button in your calculator. If you go to math and then you go over to number, you can plug it in so that your calculator doesn't have to do it piecewise. It'll do the absolute value. You could ask it to integrate the whole thing at once. But anyways, we'll be good little math students and we'll do lots by hand. Well, some of you are bigger than me, so maybe I should say just good math students. The window goes from 0 to 3. So there's the problem this time, aside from my really bad choice of window. Let's go from negative 10 to 10 and see what happens. But I think you probably figured out that some of it is now below the axes. Oh, darn it. And then above. Okay. So now we have to make this a piecewise graph. Basically what we want to do is we want to take this piece here that's underneath and we want it to be counted as a positive. So what I'm going to do then is to flip it above the axes. That's from 0, 1, 2. So it's going to be the integral from 0 to 2, but I'm going to use the negative. So again, what that's going to do is it's going to take the bottom part of this graph and flip it up here. Okay. Then the remainder of the graph is above the axes, so I can use it the way it is. So the piece from 2 to 3 can just be integrated as 3t squared minus 6t dt. And this one's not so scary that I wouldn't think it was fair. You guys should be able to do this and go t minus 2 and get a number line happening, right? If you didn't have your calculator with you, this would be your other strategy. So this would be t minus 2. And this side would be negative, positive. So here's my positives, negatives, and positives. But this is where the integral from 0 to 3 goes. So here I'd have to use the negative, and here I'd have to use the positive. Exactly the same thing we saw from the picture of the graph. And for you, it would just depend simply on whether or not you have access to a calculator. If you have your calculator, don't go spending any extra time trying to factor in anything else. Just look at the graph. It's faster and you're probably less error prone. Whereas if you don't have your graphing calculator, that's the alternative. Okay, so this one's going to become, let's see here, oops, negative t cubed minus 3t squared, evaluated from 0 to 2, plus the same thing, t cubed minus 3t squared, from 2 to 3. So in this case, I'm going to have, maybe I'll get rid of that negative sign just to make it a little easier to work with. 3t squared minus t cubed. So 0 is nice. I don't have to worry about anything with the 0 there, but I will have 3 times 2 squared minus 2 cubed. Then I'll subtract nothing. So this is the first piece. And then the second piece is going to be 2 cubed minus 3 times 2 cubed. sorry. Must have got a little excited there. 3 is the first number in that integral. From that, I'm going to take away 2 cubed and 3 times 2 squared. All right, so if I add up all these pieces here, that's going to be 3 times 4 is 12 minus 8. That's going to be 27 minus 27 times 3. Yes. Makes the math a little easier. That's a 9 times 3, so 27. Then I'm going to subtract 8 minus 12. Okay, so that's 4 plus, those are gone, becomes a 0. And that'll be negative 4, so positive 4. So altogether it should be 8. And I'll double check, but it looks like they've given us one of those really awesome choices where the answer, yep, is none of the above. Okay, so the answer is in fact E, none of the ones they've presented to us.